Here's an example of a pretzel diagram so you can see how these Venn diagrams work when you have three sets. Here I have three sets. The circle at the top, the whole circle, represents people who break into houses. The circle over here on the left is people who leave things at your house. The circle over here at the right is people who will eat your food. Now, if you look at the intersection of people who leave things at your house and people who eat your food, what do you call them? Well, they're guests. If you look at people who break into houses and people who eat your food, we get stone burglars. If you look at people who break into houses and who leave things at your house, that would be Robin Hood. Now, in the intersection here of all three, well, there can only be one person. It's actually possible to draw some Venn diagrams with sets that are more than three and show how they overlap. Here's an example of that, and I'm going to include that on the Blackboard page if you'd like to look at this one. In fact, it's even possible to do some with 5 or 6, and I'll put an example of those on. And you can just go out and Google something like Venn diagrams and get all kinds of amusing examples of this type of thing. Finally, there are 3 problems on the homework sheet, and there's several that are in the You Should Be Able to Do Problems Like section, that ask you to draw a Venn diagram to represent something. And it has several statements together. Some suggestions on how to do this would be to know some key elements. First of all, I would go looking for anything that says A intersection B is equal to the null set. If A intersection B is equal to the null set, that tells you that A and B do not intersect, and we can draw them as being disjoint. If on the other hand it says A intersection B is not equal to the null set, that tells you that A and B overlap. If you then look at the statements that deal with subsets, if A is a subset of B, what does that tell you? A is going to be completely inside of B. On the other hand, if it tells you that A is not a subset of B, well, that gives you a couple choices. A and B could be disjoint. A and B could overlap. Or perhaps B is a subset of A. Any of those are possibilities. Since these things down here have multiple combinations on how it can be done, you should go looking for these properties at the top first, draw that, and then add in the subset notations. With this, I think you can do about the first 12 problems in homework number 4. And the majority of the problems that come from this chapter are actually from section 6.1.